We're going to walk through a couple things today. I want to cover a little bit of what the operator was built for. This was covered in the last dev talk thing we did, as Katie mentioned, but I want to do a quick recap on it because a few things have changed. Also, I want to put that information sort of in perspective of how we use it, and also give you some information on the migration we had to go through with Community. And I think this will be valuable because that migration is something that you may see when you're helping a customer either get on Kubernetes for the first time or move over to the operator if they were already using Kubernetes, or to be honest, it could just be moving from one type of Mattermost deployment to another. So hopefully that information is useful. I'll throw out a small disclaimer. Because Mattermost Community Server is somewhat unique in the way we deploy it, not everything I cover will be like the gold standard of what you should recommend to a customer. Just information on how we do it, why we do it, and sort of the alternatives that you would take to do it a different way. So anyway, let's go ahead and dive in. Okay, small pro tip. If you didn't know already, K8S is a stylized abbreviation for Kubernetes. I'm going to use it a couple times in the slides, so if you see that, it just means Kubernetes. Okay, so as a quick recap, the Mattermost Operator is this cool new sort of framework that basically at the end of the day, what it amounts to is sort of like having a Mattermost cloud engineer running inside your Kubernetes cluster, managing Mattermost for you. So Kubernetes itself uses all these sort of building blocks that are different resource types, and you basically piece these together to build different application stacks. So that's the power of Kubernetes, is that it's very flexible, very fault tolerant, but there's a lot of complexity there. So one of the things that an operator, a well-built operator at least, can do for you is it sort of abstracts that away, and it presents all these resources to someone managing an application stack as just like a simple manifest usually. In other words, instead of managing a bunch of different files that sort of like are your ingress or like how you store your data, you just work with the operator and it sort of cleanly abstracts that all away for you. So that's what our operator does. It just does that for Mattermost. The other thing that our operator does, which is pretty cool, is it'll do a bunch of lifecycle management for the Mattermost server or the Mattermost app itself. In other words, like if you wanted to do an upgrade, this is normally something that if you want to know downtime, especially, you'd have to be very careful, follow a bunch of documentation steps. Obviously, if you skip a step or accidentally forget to do something, that can mean downtime or just some sort of issue along the way. The operator will take care of that for you. It'll basically ensure that your upgrades, downgrades are seamless. And if anything goes wrong, it'll stop. And we'll cover this a little bit later. And the best part about operators is that instead of thinking through what the steps are to get something deployed, like the Mattermost app, you just think about what you want it to look like at the end of the day. And the operator is smart enough, it knows how to piece together different components and in what order, so that at the end of the day, you end up with your desired state, and you don't have to worry about the road you'd have to normally take to get there. So our operator does all this. This is a common thing with every Kubernetes operator, but yeah, this is something that the Mattermost operator already does, and we're already seeing a bunch of successful deployments where all this stuff is working well. So that's just a little recap on what the operator framework is all about and what ours does. So a couple months ago, I guess, wow, time's flying, we migrated Community over from our old deployment in an AWS account to the Mattermost operator running in one of the cloud accounts. So I wanted to walk through this migration and tell you the steps we took, sort of tell you why we chose the different sort of resource types we chose. And obviously, if you have any questions, let me know. So just as a recap, Mattermost itself, it needs a couple things. It needs a database, it needs a file store, you need some actively running servers, some actively running Mattermost servers to sort of handle the workload. And then in sort of a Kubernetes environment, you also have to sort of think about what does the routing look like? How do we get to this Mattermost server in the first place? If we have multiple running, how is the load balancing working there? What is the fault tolerance like? So that's just something that all Mattermost deployments will need. And we can now show you how the Mattermost operator kind of handles all that. So as I mentioned, we had to migrate. going from top to bottom, this is basically the order we took. So when we moved from the old AWS account, we had to move the file store, which was in an S3 bucket, to a new S3 bucket. We had to migrate an Aurora RDS database over to a new one. And then we had to actively shift the workload over so that the new Kubernetes cluster was running the Mattermost server and started to handle requests for users. I'll note right now that the top two items really could be done in either order. The sort of approved method for doing as seamless of a migration as possible is you sort of want to choose a time where you either snapshot or sort of gather your data as it stands on your old deployment. And then you need to, in most cases, just make sure there's a new copy in the new environment. Now, this is obviously a little bit tricky if you're trying to keep your old deployment up. In the case of community, we basically said there's going to be downtime, and we basically turned off the ability for anyone to interact with the Mattermost server for an hour or so, and we were able to sort of use that checkpoint as our migration point to the new account. So let's go ahead and walk through the different configuration types or configuration options you need to use in the operator to get all this stuff migrated. So as I mentioned earlier, Mattermost Community is actually, at this point, a triple set of Mattermost servers. There are 3 different communities that are all sort of pointing at the same backend information. So what you see right here is actually a status view of what the operator presents to you for each deployment of Mattermost. So you see there's 3 lines here. You get a little bit of information, some mainly the image and the version. And so we have community, which is sort of our most stable version, the actively running stable release of Mattermost. We have community release, which is usually towards the release cycle's end, where it's pointing at what the release branch is looking like for that upcoming release. And then we have community daily. And that's the third one on this line, the third line there. The name is a little unique. That's because we're using some other cloud tech to manage that one. But at the end of the day, it's community daily. And you can see for community daily, the version is master and then a number. And that's because, as the name implies, every day we update community daily with whatever the most stable code is from master branch for Mattermost. So yeah, I think that's it for that one. Okay, so as I mentioned, operator presents a bunch of information to you. So you not only do you define what you want, it will actively tell you what's running. So this is one of the Mattermost deployments. This is just community, and you can see inside of the output here, you get a bunch of useful information. And the really cool thing about this is that this was all stuff that we made on the cloud team. We can expose more status in the future. So oftentimes when we're either troubleshooting a customer issue or just even looking at our own health of our own Mattermost servers, we're often just getting a quick view from the status output. You can see the number of servers running for that deployment, if it's stable or not. That's something that if it's not stable, you'll see something like reconciling, and that means the operator is actively taking steps to try to make the server stable again. You can see the version, a bunch of other useful information. So, okay, one of the items we had to migrate was the database. The operator supports 2 primary database deployments. One of them is min.io, which is a way to run an S3 compatible store inside of Kubernetes in this case. And basically you're using the cluster's storage to sort of host or keep track of the files that users upload in their Mattermost server. Now, I'm sorry, I was talking about S3. For the database, there's a bunch of options. Obviously anything supported by the Mattermost server is supported here. And there are 2 options. You can either have the database managed within Kubernetes, like I was saying. We use a MySQL operator to do that. That is more of a sort of dev-focused or trial-focused type of deployment. We wouldn't recommend that for production. That sort of deployment is just see what Mattermost looks like when you've got it all running in Kubernetes. The operator can manage all that for you, so it's really fast to spin up. A lot of our test servers that we use are done that way. But in this case, we are using external deployment, and this is our production setup. So you can see right here inside of the database section, we've defined a secret, and that is the way that the Mattermost server can connect to the external database. We're using MySQL, or I'm sorry, yeah, MySQL. And the way it works is that we took a snapshot at that downtime point we picked on the weekend, and we migrated via the AWS snapshot migration mechanism to the new account. So basically we had our old account running, we took a snapshot, moved it over to the new account, and then we had this database that we could point to. So inside of the operator, it was as simple as pointing to that new endpoint. And that secret variable you see right there is a way of Kubernetes hiding sensitive information from standard output. It basically is saying, like, there's a secret, it's encrypted, it's very secure, and I'm going to use this to connect to the database externally. So if a user or a customer were going to do this, they would just need to make this secret, and then you just tell the operator, use the secret to connect to whatever external database they want. So, oops, back up here. So as I said, we're using RDS in AWS, and we do this for a bunch of different reasons. It's very performant, very fault tolerant, and it has both of the main types of options that the Mattermost server supports for databases, which are Postgres and MySQL. So at the end of the day, if you were trying to help a customer pick a sort of backend database, really anything that you would recommend for a normal Mattermost server is something that you could sort of recommend for them here. As I mentioned, we were using AWS, and it was working great for us, so that's why we chose to continue to use it. I see Chandar left a question here. How many separate instances can the operator scale to? Basically, any number. It's up to the Kubernetes cluster size. Each Mattermost server needs a bit of resources. So if you have a very, very large Kubernetes cluster, then you're going to have the ability to scale very, very wide, as we say, where you get a lot of Mattermost servers running in parallel. And we're going to cover that more in a bit, so hopefully that's helpful. All right, so I already spoke about this a bit. The file store is sort of the second big component for something you need before you can spin up Mattermost. This is things like file attachments and a bunch of other stuff, profile pics for Mattermost. And so inside of the operator, you define in your manifest how to connect to this as well. And I already sort of mentioned min.io is an option for deployment. It's the same thing though, where we sort of only recommend that for a quick trial use, or if you're just testing out the operator, it works just fine, but it's not our production recommendation. So in our case, we were using AWS S3. And so it was a similar process where we snapshotted, or we didn't need to snapshot the S3, but we basically just stopped updating it in any manner. And then we used AWS functionality to copy all of those objects over to a new S3 bucket in the account we were going to. So once that's done, you basically have a copy of all the data. And once again, you just need to tell the operator where to find this data. I will point out the section here is called min.io. That's just a relic of how we chose to name it initially when we built the operator. And because it's sort of like an API, we couldn't just change the name very easily. So that's why it's called min.io. That said, we have a new version, a new spec coming out for our operator, the beta spec, and that we're updating the name to be much more easy to understand. We're going to call it file store. So just a heads up on that. So as I was mentioning, you have to define where to find this external S3 bucket. This is stuff you would normally have to define if you're spinning up a Mattermost server. You have to tell it where the external URL is, the bucket name, and then once again, you see at the bottom here, we have a secret value. So this is the credentials for connecting to that bucket securely, and you don't see those exposed in plain text. That's another secure connection thing. So once again, you just define this in the operator, and it knows how to use that for you. So why do we choose S3? This one's pretty obvious. It's stable, performant. You can access it globally. It's pretty awesome. There is another alternative, as I mentioned, min.io. This is sort of a less common deployment. And in the case of the operator, we really only recommend it for testing or for a demo or something. It works fine, but we're not going to plan on testing it at scale. Okay, so one of the other things you hopefully want when you have a production deployment of the Mattermost server is you want to have it to be highly available. So the great thing about the operator is it abstracts away all the complexity of getting this highly available deployment for you. And the way it does this is you have a bunch of different knobs you can can work with to sort of get the right state of what you want to try to deploy your Mattermost like. So what does that mean? It means you pick the number of servers you want. In this case, that's the replicas count right here. And then you pick, you define two sets of limits. There's a lower bound and an upper bound limit. And so the lower bound is called request and the upper bound is called limit. And in both of these cases, you can define how much CPU, memory, and a couple other things that you want your Mattermost server to either be guaranteed to have or the max it can consume. So what does that mean? Request means your deployment, each replica, each Mattermost server will be guaranteed this number of resources. So in this example, you can see it basically gets 1/110th of a CPU cycle of a CPU per second. In other words, like it gets 10% of a CPU. And then it also gets 500 megabytes of memory. And this is a guarantee. This means that if your cluster, your Kubernetes cluster is sort of overwhelmed or there's a lot going on, that at the very worst case scenario, Mattermost itself will have these resources available to it. On the flip side, we have a limit section, which that defines how much resources the Mattermost server could start to use before it maybe gets limited by Kubernetes. You can see in this case, each server is up to 2 gigs of memory and 2 CPU cores. And the reason you set this is because, you basically helps you safeguard against bugs or sort of maybe if you have a plugin that's running that could become really resource intensive, maybe you don't want that server to just like consume every bit of resource it can. You're just going to throttle it at a certain point. And so all these settings work together to sort of not only give you sort of a peace of mind that, hey, Mattermost will at least have this much, but it won't actively start consuming a ton of resources that maybe it doesn't need. And so why would you choose to do high availability? Why would you choose to set all these resources? It's so that you get that peace of mind. You know that the Mattermost application is sort of, you know like how large it could get, how small it could get before like it won't be deprived of any more resources. And as a result of all this, you can sort of do cool things where maybe your cluster wouldn't necessarily be able to support all of the apps running on it at full speed, but you know that all the resources can be shifted around elegantly and so that they can all run well on a second-to-second basis. And you can know that as one of the pieces of that puzzle, Mattermost, that it will never be deprived of resources and it'll be able to run in a performant way. So as I mentioned when we were covering the status, we have 3 deployments of Mattermost, and each of these deployments are put in something that is called a Kubernetes namespace. So a Kubernetes namespace is a way within Kubernetes to sort of group resources of a certain type and to give them security. So in this case, you can see there's a lot of, these are called Kubernetes pods running inside of this one namespace. And the namespace is that value on the left. I know it's just a randomly gobbledygook string, but that's where Community is running. You can see there's a bunch of other services running in there like Fluent, Bent, and Grafana and Kibana. That's sort of all not related to the operator. Those were just also deployed within our namespace. And you can see that because we were able to deploy these in the same namespace, they're able to, these servers are able to talk to each other in a secure way. When things are deployed in different Kubernetes namespaces, such as if you look up here, we have an Nginx router, we have Prometheus running. These are all separated into their own namespaces as well. So they can talk to each other, but not outside necessarily. So this gives you security or at least the ability to be secure. You don't necessarily have to put any safeguards in place, but it gives you the ability to be secure. And in our use case, we need the community servers, even though they're different types with different versions, we need them to all use the same file store and backend that we covered. So what that does at the end of the day is if I send a message to you on Community Daily and you're using Community, it's going to show up just like normal. And the way we achieved this was putting them all in the same namespace. I'll cover later maybe why you wouldn't want to put different Mattermost servers in the same namespace, but that's what we're doing in this deployment. So as I mentioned, why would we put them in namespace? Make sure they can talk to each other. Let's go ahead and cover why you wouldn't necessarily want to put them in the same namespace. So if you have a customer that maybe wants to do something like very segregated Mattermost deployments, let's say they have like 2 large parts of the org. These 2 parts of the org will never talk to each other without some other tool, or maybe in the future they'll all get on one Mattermost server. You probably want to deploy these Mattermost servers in different namespaces. So that way you can basically point them at separate backends. They won't be able to talk to each other if you choose to do that, which increases your security. There's a couple things to do with namespaces that sort of allow you to be you have more peace of mind about how the server's deployed. But I did want to point out that in our use case, we chose to put them in the same namespace. And if you have a deployment where someone wants to have something set up like Community, where they have different versions running, but pointing at the same database and file store, you probably want to put them in the same namespace as well. Okay, so one of the other really cool things that the operator can do is an upgrade check and basically seamless fault-tolerant rollbacks, or at least the ability to stop if an upgrade's not going well. So how does this work? In this case, we have a Mattermost application deployed, and it's got 2 replicas, server 1, server 2. They're both running on the same version right now. Now, you can think of this like Community, not even Community and Community Daily, just Community, because Community is running with multiple servers. Each one of them is. They're all running with 2. So let's say we wanted to update Community because we put out a new release. This is the way it would work. So we have the user traffic coming in right now. They're both the same version. The upgrade check starts. What this does is the operator is going to spin up a new server of Mattermost running this new version that you want to upgrade to. What this does is 2 things. It allows you to not only ensure that the server can come up and that it's healthy. You sort of get that guarantee, but you get one other thing that's pretty cool. You, in certain versions of Mattermost, are required to do database migrations, which can take a little while. This will allow you to basically spin up a new server of that version, do the database migration without affecting the old server's performances at all, and then get that done as well before you migrate any traffic. So once that's done, server 3 is brought up. Server 3 is this new version that's running. And you can see what's happened is we've shifted the traffic to server 3 once it's become healthy, and server 2 begins to be terminated. So one of the old versions of the servers is being torn down. The next step, server 4 comes up. It is also running the new version. The user traffic is migrated over, and the original server 1 is turned down. So if you noticed, this whole time we've had 2 servers up to have high availability, and we've slowly migrated the user's traffic over. And once that's done, the app is stable, you're on your new version. If anything goes wrong, where the new version is either not stable or it can't complete the database migration, you would basically be stuck in one of the steps that I just covered, but that's fine. You still have 2 servers running, they're still operating normally, and basically you can start looking into the logs on why the process failed. So sort of covered it already, but the operator gives us these seamless upgrades. And in the case of Community Daily, these upgrades are happening very often. So one of the other things I wanted to cover real quick is how do we do all of that? This is outside the scope of the Mattermost operator, but that said, it is still something that we not only use a ton on the cloud team, but we also recommend for customers. It's called GitOps. And what GitOps is all the files settings that I showed you so far, they're very important to sort of change in a sort of mindful manner, and they're also important to sort of keep track of what you're defining. So, you know, I have this one manifest that tells how my Mattermost server is running for my business. I need to make sure that changes to that are, the intent is right, that people have checked it, and that everything seems correct. So you can do that with GitOps, and GitOps in a nutshell is basically taking these files that define how the thing is deployed and you put them in Git. In our case, we use GitLab. So every day to update Community and go through that upgrade process I just covered, there's an automated build CI/CD pipeline that just kicks off. It's like, hey, okay, let's see what the newest version of the master branch that's out there that's stable. I'm going to build that real quick, push it out, and then I'm going to, within Git, I'm going to update this Community Daily's manifest to tell it to use the new version. And so that way we get a bunch of stuff. One of them is that we get this record of every time we make a change, we have that stored in Git. And if anything goes wrong, let's say something was deployed that wasn't healthy for some reason, it's really simple to roll back. You can do that within Git, just like reverting a commit, taking some code out, which is pretty nice.